Good afternoon, grade 12s, and welcome back to this session where we are doing preparation for our mathematical literacy paper 2 that will be written on Monday, the 16th of November during the afternoon. Now, before the break, I was talking to you explicitly about the type of question that we get in paper 2, and I was mentioning what we call a level 2, level 3 question, a higher order question, if I can say it so, and I showed you with tariffs how a level 3 question can actually be a question where you have to take multiple steps to get to the answer of that one. So I'm going to also quickly show you one from data handling before I move over to a cognitive level 4 question, and I also talk about measurement and shape and space. So let me show you this question of data handling that also appeared in the same paper June of 2019 last year. Now, grade 12, when it comes to data handling for yourself, it is very important that you must understand that the situations that you are going to be put in is going to be complex situations. These situations are not going to be just involving, if it is in a table, just one column, but it can involve multiple columns because that is what is prescribed for grade 12 in the curriculum. So if you look at this question from data handling that I'm now having for you here on the screen, you will see it is a question that was about whooping cough, which affects the chest and the nose and is characterized by a cough that makes a whoop sound. Now, whether you understand what whooping cough is or not, whether you know the disease or not, you should now, by reading the question, by analyzing the question, be able to answer the questions that's going to be posed regarding this situation. Like I said before, you cannot now go back to your teacher and say, you did not teach me about whooping cough. Why is there a question about whooping cough? Whooping cough is now just the context. And for paper 2, they can use context from whatever situation the examiner likes to take a context. It can be within South Africa's borders, it can be outside South Africa's border, it can be national, global, it doesn't matter what. The thing is that makes it difficult for us to prepare for paper 2 if we want to prepare specifically. So what you must more focus on in paper 2, except now to practice as many papers as possible so that you can be exposed to as many contexts as possible, is to try and focus that you will be able to apply the knowledge that you have in exactly any situation that is thrown at you. So this was about whooping cough, and it says that this table which is now going to be coming here, and like I said in the previous part of the presentation, you can really expect your information to be given to you in tables in paper 2 especially, because and it will be multiple columns also, as I have said before. So read first and check what is it that they are telling you now about this whooping cough. They said to you, what is whooping cough? It is you make a cough with this whoop sound, so you know now more or less what that is. Table 3 below then shows you data about reported cases of whooping cough and the percentage of hospitalization per age group. Some data has been omitted and some reporters' cases did not indicate the patient ages. This is some information, additional information regarding the patient that tell you what may and may not be in the table that follows. So if you look at, first of all, the heading of the table, it will tell you what is it trying to show you. It wants to show you the reported whooping cough cases and what is the percentage hospitalized of these reported cases by age group. Now, why reported cases? It means simply that it is the cases that people are aware of. Sometimes, just with this COVID-19 situation that we are now in, people get this COVID-19 without even knowing that they are having it. They go afterwards, they make an antibody test and they see they have antibodies and they realize they had the virus. So in that case, maybe that it wasn't even reported. That numbers that you see on the television is they're not including this case of this person who never reported I had COVID. The person got COVID, but it wasn't reported. The person just realized afterwards, oh, well, I had COVID. Maybe some of you have been in the same situation, that you didn't get very ill. You thought you had the flu. So you never went to the doctor, you never took the test, so they never recorded you as a COVID case. Now, just like so, the whooping cough cases is similar to the COVID cases. Some of it will be reported and some of it will not be. So they are simply talking about cases that have been reported here. Then they have on this side for you the age groups. I'm sorry, let me just go back there. They have for you the age groups, the number of cases per age group, the age incidence per 100,000, and the hospitalized per age group percentage. Ooh, lots of things. What does this mean? Let us take just the first line and we make meaning of what is in this table. Because if you're just going to start and you are not going to be, you did not acquaint yourself with this table, you are not going to know what is going to be that expected of you to do. Or you're going to be maybe lost in somewhere in this whole thing. So let's just look at the first line. They say, the children that are less than 6 months. And if you want to know if 6 months is included or not, the word less than show you that it's not included. And then if you look in the second line, you will see from 6 to 11 months. So these kids can be newborn, 1 month, 2 months, 3 months, 4 months, 5 months, and just before 6 months, but they are not yet 6 months old. So the number of cases of whooping cough that they have recorded for this age group is 1,280. In other words, 1,280 babies who got whooping cough and they are under 6 months out. Now the age incidence per 100,000, they say it is out of this cases, 64.5 of the cases will be this age group, which is babies. And then hospitalized per age group, what percentage are hospitalized? Of this 1,280 babies, not all of them is going to be going to hospital. Some of them will get just mild symptoms and the parents can look at them at home. But of this 1,280, about 44.2% will be hospitalized. And so you can look, the cases of babies of 6 to 11 months, just be a little bit of bigger baby, they are not a year yet, 612 cases, age incidence per age group 30.8, 11.5%, significantly less number of babies have to be hospitalized. And if you go and get now a view over the table, you see, okay, I can see the age group that is possibly the mostly hospitalized is that 44.2, and then the 6 to 11 months. So it looks for me, okay, and then older people again. Wow, older people is also hospitalized, but not as much as babies. So you start getting a feeling of what is in this table. And then the number of age groups will, of course, correlate with this, where you will see, okay, this is the number that are hospitalized, that have to go to hospital. You will see, if you look at babies, are they the most who must get the whooping cough? Now, then you say children 1 to 6, they are getting whooping cough more than babies. Yeah, and 20 years and older, yeah, there are also more cases of whooping cough. Here for babies and for bigger babies, it's actually less. But they are more likely to go to hospital. So you start getting a sense of what is in this table. What is this table wanting to say to me? Yeah, there's not so many cases as in the case of the 20 years, but there's a high percentage of hospitalization. So I start getting a feeling of what is happening there. Now, the two questions that I want to focus on here with you is, first of all, it's a level 2 question, and then the second one is going to be a level 3 question. And I will explain to you why then it is a level 3 question. Now, the level 2 question, let me just go. The level 2 question that we have then here is, let us just first look. N represents the highest number of whooping cough cases for known age groups. And the range for the number of whooping cough cases for the known age group is 4,527. So determine the value of N. And if you go back into the table, the value of N is the number of cases per age group. So this whole thing that they talk about here is then the number of cases per age group. So we are going to be in a specific column in the table. So what I am going to do now is I'm going to move over to my piece of paper. Now what I like to do, especially in paper 2, is I like to write what is given to me. What is given to me? It is given in that question that N is the highest number of cases. Okay? Obviously, they use a N because it is not known. And I believe they use a N because of that number of cases. Then the other things that they gave me is, they say, what is the range? They say the range is 4,527. And now, what is the question that they ask you? Question mark. What is it that they want you to get? They want you to get N. What is the value of N if you go and look in this table? Now, obviously, since N is in this one, and we are talking about the number of cases, I am currently working, if I can do this, or if I can do this, I'm working with this column. Okay, so they said that N represents the highest number of cases. And they spoke about the range. Now think just about your definition. You see, many times in Math Lit paper 2, you get lost in the wording. You get lost in the way that the question is presented. But if you can just recognize the word range, and you realize that you know what range is. Range is the highest value in a data set minus the lowest value in a data set. Then you know that you can at least work with the range efficiently. Now, if you go and look, in this case, we are talking about the data now in this column, remember. Ne? The range was given for 4,527. So it is not one of these two values that was given. It was in fact this what stands on this side of your equal sign that was given. So the range is given as 4,527. What is the highest value? The highest value I wrote here, N, is given as the highest number of cases. So the highest value is N. And then minus the lowest value. Now, oops, what now? Where is that lowest value? Ach nee man, we were given N, the highest number of cases. We were given the range. Don't despair. Go back to the data, to what was given. What was given was the table. What you are working with is this column. Look at this column. There are different values. I know that this is the biggest value. This is the highest value. All that I must do now is I must go and find the lowest value. And I'm going to find it in this table. What is the lowest value in this table? Go through all of them. The lowest value is 76. Or is it, okay, no, wait. There was a catch in this question. Before we use 76, let me just go back to this one here. There is a catch. Because here they say, N represents the number of working cases for the known age groups. For the known age groups. So those age groups that they know what they are. And if you now go back and you go to here, you will see this 76 doesn't belong to the known, it belongs to the unknown. You see, this is what paper 2 like to do. Paper 2 like to throw you a little bit around. So the 76, yeah, it is the lowest value, but it's the lowest value of unknown age. And they explicitly ask you to work with the known ages. So let's cover 76 and let's go to what is left. What is now the lowest value? Aha, now I can see the lowest value is 612. So in the place of the lowest value here, I can write 612. Now it's easy. I need to change the subject of the formula. Now, whatever I minus on this side, if I go with this to this side, I need to add it. The reason for this is, if I add here 612, this part will become like 0. Minus 612 plus 612 is 0. But if I plus 612 on this side, I must plus 612 also on this side. So at the end of the day, remember this is a minus sign, it's not a multiplication sign. So at the end of the day, if I want n, I must add 612 and 4,527. And now you can say n is equal to, and if you add those two values, you get 5,139 is then the value of n. And what I like to know, it's the highest number of cases. I write it always in here, 5139. The moment I work out a value that was in a table, then I like, after I got my value, to write it here, so that I know I worked it out already and that n is not there, and I keep on paging on what is it now that I need to go and find. Just a little bit of maybe some idea that you may check. Will you say that this data that is here is discrete or continuous? If you go and look at the data represented here, it is of course discrete, because it is whole numbers that I am representing each one of these. It's whole numbers of cases that I'm having. If you look at the age groups, or how the age groups have been arranged, they are arranged in a continuous way. From 0 to 6, where it stop, it start. 6 to 11. It stop, now you start with 12 months, which is 1 year, to 6 years. You stop, you go from 7 to 10. So these data flow. It is continuous, it's going on and on. But the data that you here see is whole number of cases. There is nothing in between these cases, these numbers in the data set, if I can say so. If you are also going to represent this, you are going to probably represent it with just a dot. Okay, so this is a typical level 2 question because it is asking you to work out a highest value where a range and a lowest value was given. Question 1 would have been just to go and work out a range. If they give you the highest value, they give you the lowest value, you subtract the two values, then you get a range. Okay. So let us move for a moment back to my other question that I want to do with you. I want you also to always observe the marks. This question counted 4 marks. I can tell you now there's no way that the question will count 4 marks if they just want you to work out the range. That 4 marks tell you that that is not the ordinary range question. You need to do something else. And the something else was you had to change the subject of the formula. Now let us go to this one. Determine the interquartile range only of the known age group. Again, please take note they excluded the unknown age group for the reported number of whooping cough cases per age group. The whooping cough number of cases per age group. I'm still busy working with this column. I'm still working with the number of cases per age group. Okay, I've identified the column. I am still not working with this because it is still an unknown case. What is it that you are going to have to calculate? They ask you to calculate the interquartile range. Now ask yourself, what do I need so that I will get the interquartile range? This formula must be known by you. Now to get the interquartile range, I say Q3 minus Q1, or we also call it the upper quartile minus the lower quartile. Okay, so to be able to get these two things, the upper and the lower quartile, what must I do with my set of data? Remember, what I'm working with is with this column, and in this column there are some values. The first thing I'm going to have to do is I'm going to have to write this data in ascending order. So the smallest value is going to come first. I'm going to write in ascending order. The smallest one must come first. Now, which one is the smallest one? The smallest one is definitive the second 612. Now, which one is the next one? The just bigger than 612. Here I have 1,000, 3,000, 2,000. This one I wrote it most now in is a 5,000, a 3,000. So the next one will be 1,280. So I like also when I have written something down to make it some sort of mark so that I can remember I already wrote this one down. I also already wrote this one down. The next one that I'm going to write is then going to be this one, which is 2,221. I'm scratching it out. Then, which one is first, 3,051 or 3,451? Definitely the 3,051. Okay, I've used this one. The next one is 3,429. And then N is 5,139. Grade 12, what I want to say to you, if you could not work out N, don't leave it out here. Go and get a value for N so that you will be able to answer the next question. Hence, my advice is always never leave a question. Because if even it is the wrong value of N and you bring it here, we are going to accommodate that wrong value when we do the marking, and we will mark it then according to the wrong way in which you calculated the previous value, but you brought it correctly here. Okay, ask your teacher to explain that concept for you, maybe clearer. So here I've got now an arrangement If you feel uncomfortable to arrange it from there to here, then first write them down. 1280, 612, 3051, 2221. Just write them first down so that if you are going to work with them now further, you have them already in front of you. Sometimes it's difficult to work between a column and some numbers. So then when you start arranging, you can say, okay, 612 is the smallest. The next one will be 1280. The next one will be 2221, 3051, 3429, and 5139. There you see all the numbers. But ultimately, you are now here. To be able to get the quartiles, you need to order the numbers. Now, to get the quartiles, I am simply going to find, first of all, Q2, and then Q1, and then Q3. Now, how do I find Q2, the value in the middle? Q2 is also called the median. Now, the one way in which you can do it is by simply scratching the first number and the last number. Then the first number and the last number. And then you will see, I'm left with two numbers here in the middle. So if I'm left with two numbers here in the middle, then to get the median, I'm going to have to say 2, 2, 2, 1 plus 3051 divide by 2. But I'm not so interested in Q2, so I'm not going to waste my time further on this. I want my Q3 and my Q1, my upper and my lower quartile. But bottom line, what you must understand is that that median is between, halfway between this value and this value. So if you want to, we can say, okay, Q2 is here. Now, if you are going to get Q1, you are going to have to get the middle value of what is then to the left of Q2. And to get Q3, you're going to get the middle value of what is to the left, to the right, my right, of Q2. So here you are left with three values. So if I go now with these values, let me just get for you another color. Let me put it, there is now these three values. Now I get the median again. This one, that one. Then I can clearly see that the median is this one. The median of this first part. And then I call this Q1. On that side I have three values. What is in the middle? I have 1, 1, 1, and then I have my value in the middle. That one, I call it Q3. Can you see, when I started off with the data, here was 1, 2, 3, 4, 5, 6 data pieces. 6 is what we call an even number. Now, the 6, if I divide it in two equal groups, I will have 3 groups on this side, and I will have 3 groups on that side, or 3 numbers of the data set. So, if I have an even number and I get a Q2, then it's going to be between two numbers, that median. But now, if I have an odd number, like 3, that value that I'm looking for is going to be on one of these values. So there are 3 values. You've got one on either side and one in the middle. It falls exactly on the value of 1280. And the same on that side. I've got 3 values. There is one on the one side, one on the other side. It falls exactly on 3,429. So I can now conclude that my Q1 is 1280 My Q3 is 3,429. So if I want my IQR, my interquartile range, and I simply say Q3 minus Q1, then Q3 is going to be 3,429 and Q1 is going to be 1,280. And if you subtract those things, you get 2,149 as the answer. Now, why is this a higher cognitive level question? It is because you must first go and determine Q1, Q3. Actually, what you must first do is you must first order, you determine Q3, Q1, you determine Q3, and then you determine the interquartile range. So you had to take multiple steps to come to this part. And therefore, it is a level 3 question. If we subdivided it, said for instance, this was question 3, and we said 3.1, get Q1. 3.2, get Q2. Then 3.3, get IQR. Then it is not a level 3 question, because then we say this question is scaffolded, it is broken down. If you go and look at the number of marks that this question count, you will see it counted 5 marks, meaning that there's more work to be done than for this 4 marks, and meaning that it's not just a simple thing, it's not just one value subtract the other value. If you are just going to say big value minus small value, you are totally oversimplifying what should be happening here. It is 5 marks. Let the marks lead you. This is more work. Grade 12, then I just want to also talk to you a little bit of level 4 questions. I chose level 2 and 3 to discuss that with you with finances and data. So level 4 question, I'm going to discuss that for you with measurement. Now, and shape, space, and other representations of the physical world. I'm sorry, I just don't have time to do level 3 questions for all the different topics, level 2 questions for all the different topics, and also level 4 questions for all the different topics. So I'm moving over to the other 2 topics. Okay. Colleagues, let us remember that when we talk about maps and plans and other representations of the physical world, and you saw that it can take up to 15%, when it comes to these maps and plans, it can be different things. Here, for example, we have an ordinary street map. Now, it is a street map where the streets are clearly shown. Okay, this specific street map that you see here was a street map was in Denmark. Hence telling you that it can be from any part of the world, it can be from anywhere, anytime. You cannot now go and say, I don't know Denmark. No. You need to come now and say, I know maps. And this map, being from Denmark or from wherever, I need to be able to read it. Because tomorrow you may become a traveler, you go overseas and then you cannot read the map because you only read maps of South Africa. That won't do. That is not what we want in MAVLAT. We want learners who are multifaceted. So, in this specific map, I'm not going to do a question on it. I just want to show you 1 or 2 things. When you are working with a map like this, you will get sometimes on the side, they will give you what we call a key to help you with interpretation. This map came without a key. So you must use your common sense to interpret some of the things on it. Like, for example, this Denmark hotel that you see here, which I'm highlighting. If you look next to it, you will see there's a little picture. Now, I'm sorry, this picture was maybe not 100% clear to you, but it is a guy in a wheelchair, or a man in a wheelchair. It's a person in a wheelchair, if I can say so. Now, you must then think for yourself, okay, what does this person in the wheelchair mean? Okay, there is a person in a wheelchair. Here is another person in a wheelchair. What can that be? Now, one of the questions in this specific paper was how many of these landmarks that you see on this map has access for people with wheelchairs. Then you must immediately make the connection. Oh, this is what these wheelchairs are about. It's about people that can access this hotel with a wheelchair. Okay, and then you can simply just go and find all your wheelchairs. There was a little wheelchair, here is a little wheelchair, there is a little wheelchair. Just make sure that you find all of them. My map is now not so 100% clear here, but it looks to me like those are the wheelchair ones. The second thing that I want to bring to your attention is that this map is working with a bar scale. Remember, we get our bar scale or graphic scale versus our numerical scale, which is presented by numbers. Now, in order to be able to work with a bar scale, you need a ruler because you are going to measure physically the distance, maybe say from 0 to there. Then if you measure it with your ruler, you can equate it to 200 meters as it's given there on the bar scale. So a very important thing for you to remember to bring on Monday is a ruler, grade 12, a ruler. Because it may just be so that you must measure something and then you need a ruler. Very important. Okay, then you will see here are different streets, there is a whatever here is a river. Please, it says Denmark River. This is not a street. You must obviously be able to see that it looks different because it is colored in. And so you will, before you just start answering questions, just check out more or less what is this thing that they are giving to you. Instead of giving you a map, they can also give you a layout plan. This one was also in an old question paper. The previous one was also in an old question paper. And this layout plan that they have here for you was of stalls at an education fair or something like that. You will see here the floor plan and the layouts of stands in the International Education Fair. So you don't have to get a map. You can still get something like this layout thing and it will still represent for you, fall for you under the topic of maps and plans. Fortunately, this one here has a key. Now, if there is a key, try to understand what the key is trying to say to you. It is a layout of stands at the International Higher Education Fair. International meaning different countries or countries above South Africa, more than South Africa. And then you will see here is Spain and you will get numbers, Germany, and here is number. So obviously if you go and relate Spain now, you will see Spain is in all of these, LO1, LO2, LO3, all of these are Spain. And Germany, LO4 to LO6. So all of these are Germany and so on and so on. So at the end of the day, this is now also what I want to mention to you is that a question such of probability can creep in here, for example. This will be a brilliant place to put a question of probability, where I ask you, what is the probability of finding a German stand in this higher education fair? So if you go and look Germany, 4, 5, and 6. 4, 2, 6. That stripe means 2, 6. 4, 5, and 6 is Germany. So 3 stands belong to Germany over the total number of stands. So what is the total number of stands? You must just now be careful because some of you might think, okay, if this is a 1, then maybe I must end here for the last stand. But oopsie, that is L46. That is not the last stand. L47, 48, 49, 50, 51, up to 54 is still here. So, I have a total of 54 stands. Better more, you can go and count quickly all the stands that are given. It can also be seats in a conference center, or it can be in an auditorium or anything like that. It all boils down to the same principles. You need to be able to apply those principles to whatever situation is given. So if I then want to determine the probability of finding a German stand, I'm simply going to say 3 can be German over the total, which can be 54. And then the examiner can specify for you that this is now your probability of finding a German stand. And you saw that it is 3 over 54. Now you must look. Many times on your paper you will find a specific way in which they want the answer. In the case of probability, they can say, give your answer as a percentage. If they say give it as a percentage, you are simply going to multiply it with 100. So as a percentage, you will say 3, there's my calculator, 3 over 54 multiply 100, and it will give you 5,55%. But now, make it 5,56%. In this case, you can also round to one decimal number. You can also say 5,6%. They will both be correct. So, if I give it as a percentage, it is 5,6%. You can also give it as 5,56%. I will not give it as a whole number because then you are pushing it maybe a bit far. Alternatively, they can say give it as a decimal number. Then if you give it as a decimal number, you need to simply say on your calculator 3 divided by 54. Not multiply 100. In other words, you need to just say 0,05. I will say in this case 0,056. But you will not be wrong if you say maybe 0,06. At least one of the two. Okay. The other thing that they can do is they can say, give it as a fraction in the simplest form. So what you can do then is, I always first check, this is obviously the small number, the bigger number. Can 54 not maybe be divided by 3? 54 divided by 3. Oh yes, it can. It's 18. So then you can just say 3 go into 3 once, 3 go into 54, 18 times. And that will be your fraction in the simplest form. Answer the question. Whatever they ask you and whatever they specify, make sure that you answer the question. If they say they want it as a decimal, give it as a decimal. If they say they want it as a percentage, give it as a percentage. If they say they want it as a fraction, in the simplest form, give it anyway, even if they just say they want it as a common fraction. We call it a common fraction. Even if they just say common fraction, give it also in the simplest form, because sometimes they don't say simplest form, but they want simplest form. Okay, just back to our presentation. Another type of map that was also recently asked, and I think you also saw it very well in the September examination, there was an elevation map of a marathon. That September was of the Boston Marathon. Here is a previous one that came from an old exam. paper. And this is not an elevation plan. It doesn't show you how high are the points above sea level. No, it is more or less a map which show you how are the runners going to run. And at some places they say, okay, now the distance is this. Oh, they do specify the height. They say the distance that the runner has run is 15 kilometers. The height above sea level is 1,485. Here, there is a key, and the key is giving you information, which says that H stands for the height above sea level given, and D is the distance from the start. But this is not an elevation map per se. It is just giving you the distances above sea level. They will show you a height, like you had in the September exam paper 2, where the height was given, which showed you then that it's an elevation map. So if you look at this type of map, make a little bit of sense. What is happening here? It's a full marathon map. It says 42 kilometer full marathon map. Later on, they do ask in the question paper, how long is a full marathon? And then you just need to see, you know what I love about maps and plans is that the information is there in front of you. You must just open your eyes. Here it says 42 kilometers is the full marathon. So if later they ask you how long is a full marathon, then you say 42 kilometers. Hence I was saying in the beginning of my presentation that this is a section where you must do well. Open your eyes. Look for something. Look for what you are, what it is that you need to answer about. Here are also some symbols which represent then certain things like this will show you the marathon route, the water station. Can I just show you, you know what I realize is sometimes people get a bit confused, and you must please, this marathon route, that arrow there, and the arrow here is not the same thing. If you look at that arrow, you will see it's a kind of a long arrow like there. A long arrow with an arrowhead. That is the marathon route. And you go around, and then there is an arrow with an arrowhead. That is a marathon route. These thick things here, they are lodges. It is the lakeside lodge, okay? And here are the ravine side lodge. This is not this arrow. Can you see the difference? Then you have also water stations, coke stations, medical stations, energy drink stations, banana stations, personal supply stations. Now, unfortunately, here you see it in color, but in your print on Monday, there's going to be no color. So it's going to be like this. You are going to have to see in black and white that this is the same as this. There will be no blue there on your question paper. That I can guarantee you. It's printed in black and white. It's by accident because I got this from the original paper that this is in color. Okay, now what kind of question can you expect in a map also? We have now looked at the probability question. The one thing that I want to talk to you about, this one was in the paper, but it's an ordinary level 2 question, and it only counts 2 marks, so it's short. In Mathlet anyway, nothing counts 1 mark. Everything counts 2 marks. Or it starts at 2 marks, sorry. Everything does not count 2 marks. Everything starts off by a minimum of 2 marks. Gives the general direction in which a marathon runner is heading when passing the 20-kilometer mark. Now, if you go back, I will come back to this answer now. I first want to go to the map. Where on this map is the 20-kilometer mark? You will see here it says the distance is 20 kilometers. I'm talking about the distance from the start. And it's clearly indicated that it is there at that point where you get the 20-kilometer mark. So what I do is I go and construct there a little axis. There at that point is the 20-kilometer mark. Then I go and I make sure that I find north on this map. North in this case showing that north is in that direction. Grade 12, it's very possible that north can also be pointing downward. So go and look in which direction north is going. Now, in which direction will you be running here when you go to 20? Here is an arrow that shows you coming here in this direction. You come from here. You run, go around, run. So when you come here to the 20 kilometer mark, you are going to run in that direction. Do you see that? You are going to run in this direction. And what is this direction? There is east, there is north. So the answer, if I go back, is not north, it's east, it's southeast, or east of south, or southeast. Let us just go again. Sorry, I'm now confusing you. North is pointing upward. There is your mark. So here is east, north is up. Here, grade 12, tiredness. Here is north showing up, south showing down, east on this side, west on this side. So there is east, there is south. And you know that you must always name this axis first. So call it southeast. Do we have it now? It's southeast or east of south. You can also write, but we prefer the correct thing is actually southeast. Let me just do with you another relative direction one, because I see learners are not getting this right. Everything is on the map except relative direction. You need to do relative direction. Say for instance, I'm asking you, in which general direction is the 40 kilometer mark from Lakeside Lodge? Now there is Lakeside Lodge. What you do is, if I say the 40 kilometer mark from Lakeside Lodge, then there at Lakeside Lodge, you go and make your cross. Then from that cross, because actually it must be here exactly in the middle. Okay, I'm sorry it moved a bit there, but here is Lakeside Lodge. Lakeside Lodge is not there, it's not there, it's not there. Look for the specific place where you get the Lakeside Lodge. So here is Lakeside Lodge. Then you go and you put in your marker towards the 40 kilometer mark. And in which general direction is the 40 kilometer mark from Lakeside Lodge? And the general direction is directly south, because you know north is there, south is there. Let me just go back. Let me fly it in again. There is Lakeside Lodge. There is your markers. There is, you make a line to the 40 kilometer mark, then you see it's directly south. Now, if I ask you in which general direction is the 30 kilometer mark from Lakeside Lodge? Here is Lakeside Lodge. There is your set of axes. There is your 30 kilometer mark. So again, there is your east, there is your south. So again, southeast. Grade 12, we are almost out of time. I just want to show you a level 4 question and say one or two things about it. Here is for level 4 question where it is integrated that maps and plans is together with, are in the same question. Let us just look at it. They say for the half marathon, half run or marathon is 21 kilometers. A runner must cover a distance of 16.5 kilometers in a time of 5 hours from the start of the race to beat the cut-off time. The cut-off 2 time. Now, if you go back to the map, you will see there's different cut-off times for the half marathon. A runner of the full marathon compared his speed. We are going to compare speeds with the speed of a half marathon runner, and stated that he had to run 2.7 kilometers per hour faster in order to beat that cut-off 2 time of the full marathon. Verify showing all calculations whether he is correct. When you get a question like this and a formula is given, like in this case, they say distance is speed multiplied by time. Immediately start by writing the formula on your exam book. Namely, distance is speed multiplied by time. Do it and don't change it. Write it just like it is on the paper. You will see this is a 6-mark question. So it means you're going to do a lot of work. The moment you see the word verify, then it means that at the end of the day, you need to make a conclusion of some nature. You need to say whether this person is correct or incorrect, right or wrong, yes or no, but you need to answer some question. Now, in the first part of this question, you were given that for a half marathon runner, he must cover a distance of 16.5 kilometers in a time of 5 hours. So you are given a distance and you are given a time. You are going to have to work out the speed so that at the end of the day, you can compare speeds with each other. So what you're going to do is, the formula is given to you as distance is speed multiplied by time. What I will do if I am you is, I will simply go and check what is the distance, which is 16.5. I will write 16.5 kilometers here with this distance. The speed is not given, and the time that is given there is 5 hours. So I will write that immediately, because now you already have a mark of substituting correctly into the formula. Now to get the speed, some of your teachers teach you the triangle, namely that distance is speed multiplied by time. So you will immediately know that if you want the speed, you must say distance over time. Alternatively, if you wrote it like this, you can now see I am multiplying with 5 on this side, so I must go and divide with 5 on that side. So if I say speed, and it's quite okay to keep it on the right, you don't have to take it on the left, is 16.5 kilometers over 5 hours. And if you work this speed out, you see it is simply 16.5 divided by 5, and it's a speed of 3.3 kilometers per hour. And grade 12, if you get here a speed of 3,000 kilometers per hour, you must think that something is wrong, because there's no way that a person can run so fast. A human being can only do so far. So this means this person can cover 3.3 kilometers in 1 hour. Now, if you look at the second bunch of information, a runner of the full marathon is now going to compare his speed with the speed of the half marathon runner. And he is stated to run 2.7 kilometers faster. Now, in case you think to yourself, no, I'm not seeing anything that can help me, there was some additional information that you need to be able to get. And this was, you can clearly see there at the question, there is no information. So you must go and look for it somewhere else. So we are going to work with cutoff 2. We're going to work with this value, with this distance and this time. So if I go now over and I say distance, the formula which is on the formula is speed multiplied by time. The distance that cutoff time is having is 31.5 kilometers. The speed is the thing that I need to work out. And the time, it's given in that thing, it is 5 hours, 15 minutes. Here is now a little slack. That 15 minutes cannot, is this 5.15 hours? Is it? Grade 12. It is not. If you want to work out 15 minutes, you need to first go and convert it to hour. And how do I convert it to hour? If I want to convert that minutes to hour, I'm simply going to say 15 minutes divide by 60, and it's going to give you then 15 divided by 60 gives you 0.25 hours. So, if I want to go back to now what I wrote now here, 31.5 kilometer is the speed multiplied by 15.25 hour. You simply say, not 15, 5 plus 0.25. That 5 hours, and you add the fraction that you are having. So now if you need the speed, you must simply say 31.5 kilometer, and you must divide it by 5.25. And if you do that, 31.5, there is the calculator, divide by, let me just clear it totally, 31.5 divide by 5.25, it's a full 6 kilometers per hour. And that's fast enough, I can tell you. That is more or less the speed that a human being can run. And it is quite a reasonable answer. Now, remember to answer the question. And how? By looking at what they asked us. This guy said he had to run 2.7 kilometers per hour faster to beat that time. So, if that time that we calculated is 3.3 kilometers per hour, if this guy is now going to run faster, he must run 2.7 kilometers per hour faster. So if you add 2.7 kilometers per hour to that 3.3 kilometers, what is it that you're going to get? And if I do it on my calculator, I get exactly 6 kilometers per hour. And if I compare this with what I got, what he is running, then answer the question. He is correct. This is a mark. If you are not going to answer your question, you're going to lose the final mark. Grade 12, I'm shortly going to summarize because I need to finish off. The few tips that I wanted to talk to you about, or that I spoke to you about this afternoon, just again, general things that you must please remember for Monday. Answer the question in whatever order is good for you. Whether you do question 4 first, you see it's data handling, you like it, you do it. You see question 1 is finances, you love finances, you do it first. It's your choice. Leave lines open between your answers, please, so that it will be clear for the marker and no oversights can take place. Do not write too close to the question number. I showed you what can happen if you write too close to the question number. Ensure also that you number the questions correctly, because sometimes you see that you know the answer of a later question and now you write a wrong number with it. Don't. We are not going to mark it if it stands at the wrong number. Ensure that you actually answer the question. What I said to you now, answer the question. What I said to you earlier, answer the question. Don't forget to answer what they are asking of you. Ensure that you consider rounding. Money is 2 decimal places. There are other situations where you can choose 2, 1, 3 decimal places. You can also sometimes do whole numbers. It depends on the question. And if there's a specific instruction, follow that instruction to the letter. Answer all the questions. Grade 12, you don't leave that room before you did not answer all the questions. You can only stand up before the 3 hours is finished if you answered all the questions. If you write something, we can mark it. If you write nothing, you have 0. So, write. Please, we are getting paid to mark your paper. Everybody who sit there is getting paid. Let them sweat for it. Write, write, write all your answers. You answer it to the best of your ability. Bring your equipment on Monday. Bring your calculator. Make sure that you know your calculator. And make sure that you bring your ruler. And then finally, my best advice is, don't just dive in. First, get an idea of what it is that you must do. Make marks with your pen, with your pencil, with your toes, with your fingers, whatever you have to use. Write in sweat if you must write there. But try to highlight whatever it is that is given on that paper. Analyze the questions. It is paper 2. It's going to deserve more thinking. And I'm just now thinking of something that I didn't write there. Let the marks guide you. If it counts 10 marks, grade 12, you cannot write 2 lines. Ha! No, never. Never. If it counts 5 marks, you cannot even write 2 lines. Let the marks guide you on how much it is that you are going to have to write. Grade 12, that is all that I'm having for you this afternoon. I hope this is going to help you in your preparations for Monday. Please know that all of us are with you in our hearts and that we are only wishing you the best of luck for the examination. It is our prayers that you will only do your best. When you come and sit there, make sure that you do your best. Like I said when I started, make sure that you drink water, that you are not dehydrated by the time it's 2 o'clock and you come and sit there. Make sure, take a brisk walk before you must come there so that you can really feel alive when you come and write your math lit. Good luck with you, your examinations. For your teachers who are still standing in front of you over this weekend, go on back to them and say to them, thank you, teacher. Most of them are standing there because they love you, for no other reason. And I'm thanking them also because they are sacrificing, but it's all for the better good so that we can all have a better life in this beautiful country of ours. So teachers, thank you, thank you, thank you. Learners, you go back and you say thank you to that teacher, whether you like that teacher or not. I'm telling you, they are sacrificing so much for you every day, working night and day, not having time with their families, making you their family. I'm wishing you all of the best, and I'm praying that it's going to be the best paper ever for you. Thank you so much for listening to me.